This is the Arch Method 143. Before this motorcycle leaves the workshop, Keanu Reeves personally rides it, every single one, not as a publicity stunt, not to sign the tank and take a photograph. He puts on his helmet, rolls it out of the workshop bay, and rides it hard enough to know whether it's right. If the throttle response isn't what it should be, it comes back. If the suspension is off, it comes back. If anything about the motorcycle doesn't sit correctly with him, it comes back and gets addressed before the shipping crate is sealed. The bike doesn't ship until he says it ships. That isn't a marketing claim. That's the actual quality control process for every single unit this company has ever produced. There are fewer than 100 of these motorcycles on Earth. Each one took more than a year to build. Each one was physically custom-fitted, not adjusted, custom-fitted, to one specific human body before it ever turned a wheel on a public road. And each one starts at $130,000 before you've chosen a single option. Keanu Reeves doesn't lend his name to this motorcycle. He built it. The engineering philosophy, the fitting process, the absolute refusal to compromise build timeline against output volume, all of it traces directly back to a decision he made in a Los Angeles workshop in 2011, when he concluded that nothing on the market was good enough, and so he would build something himself. This is what happened next. Arch Motorcycle Company started the way most genuinely interesting things do, with one person being dissatisfied. Keanu Reeves had been riding for years by 2011. He rode for pleasure, and he rode seriously. But he'd never found a production motorcycle that truly fit him. Seat too high, bars not quite right, weight distributed in ways that didn't suit his frame and his riding posture. He'd tried aftermarket solutions. He'd had bikes modified. None of it resolved the underlying issue because none of it started from the right question. The question isn't, how do we make this bike accommodate a wider range of bodies? The question is, how do we make this bike fit one specific body precisely? So Keanu went to a designer and fabricator named Gard Hollinger, working out of Los Angeles, building custom motorcycles for a small and serious clientele, and asked him to build one from scratch with exactly that question in mind. Not to modify an existing platform, to design a motorcycle from the ground up around one rider's body, and from that process derive a method that could be applied to any buyer. The original result was the KR-GT1. It was unveiled in 2014. It won a design award at the International Motorcycle Show that same year, which was genuinely not what anyone had expected from an actor's side project and says something rather clear about what the project actually was. This wasn't a vanity exercise, it was a genuine engineering commitment. The Method 143 came later. Bigger displacement, more extreme chassis architecture, more ambitious in every measurable direction. But the philosophy is identical to the KR-GT1. Every motorcycle Arch builds is fitted to one specific person's body before it leaves the workshop. Not adjusted, fitted. Those two words aren't interchangeable, and in this video we're going to find out precisely what separates them and whether the difference genuinely justifies $130,000. We've recreated the Arch Method 143 in intricate detail, the Monocell chassis, the custom fitting process, and the S&S V-twin at its heart, to show you what happens when a Hollywood actor decides that building a better motorcycle is worth doing properly. This is bespoke. Start with the numbers. The Method 143 runs 93 inches in total length, 2,362 millimeters. That puts it squarely in large displacement American cruiser territory. Nothing there is particularly surprising. Wheelbase sits at 66 inches, 1,676 millimeters, standard parameters for this category. Then you get to the weight, and that's where it gets interesting. Dry weight is 490 pounds, 222 kilograms. Here's why that number matters. A Harley-Davidson Road King, a motorcycle you might reasonably compare the Method 143 to in terms of displacement and intended character, comes in at around 368 kilograms wet. Most comparable, large displacement cruisers fall between 290 and 380 kilograms, depending on specification. The Method 143, with a larger engine and a full hand-laid carbon fiber chassis, is lighter than any of them, around 140 kilograms lighter than the Road King. That's roughly the combined weight of two fully grown adults that Arch has engineered completely out of the picture, on a cruiser, which says everything you need to know about how seriously the engineering ambition was taken from the beginning. Handling that figure in context also reveals why the carbon fiber monocell matters so much. A conventional steel-framed cruiser with this engine displacement would weigh considerably more. The weight saving isn't a bonus feature, it's the entire engineering thesis of the bike made tangible as a number. The name tells you what's under the tank. Method 143, the number refers to the engine's cubic inch displacement. 143 cubic inches is 2,342 cubic centimeters. For reference, Harley-Davidson's largest current production engine displaces 117 cubic inches. The S&S unit in the Method 143 exceeds that by more than 22%. Arch didn't build a large motorcycle and fit a slightly bigger engine. They built the biggest engine they trusted and engineered an entire motorcycle around its requirements. Seat height starts at 27.5 inches, 699 millimeters, as a reference baseline. But that figure doesn't describe your bike. Your seat height will be determined by your inseam, your natural sitting posture, and the angle your femur produces at a given saddle position when your muscles are genuinely relaxed. The buyer who took delivery before you may have a seat 40 millimeters lower. The next buyer may have one 30 millimeters higher. Every finished bike is dimensionally different because every rider is dimensionally different. The 27.5-inch figure is a starting point and nothing more. In 15 years of production, Arch has built fewer than 100 of these motorcycles. That isn't a slow sales quarter. That's a deliberate production rate from a workshop that treats quality as the only non-negotiable. The waiting list runs to at least 12 months from deposit, and it's been that way consistently for years. People wait. Here's what makes the Method 143 genuinely different from everything else at this price. And it isn't the engine, and it isn't Keanu Reeves's involvement, however significant both of those factors are. It's the chassis. Specifically, the carbon fiber monocell. On a conventional motorcycle, the frame and the bodywork are two entirely separate systems doing two completely separate jobs. The frame is structural, aluminium or steel tubes, welded or bonded together to carry load and connect the suspension, engine, and wheels into a coherent unit. The bodywork is cosmetic, panels and fairings fitted around the frame to give the motorcycle its visual shape. Two distinct design briefs. Two separate manufacturing processes, built independently and assembled together. The Method 143 doesn't work that way. The monocell is a single unified structure, frame and body, in one piece. The carbon fiber surfaces you're looking at aren't covering a frame underneath. They are the frame. Every panel is load-bearing, every curve carries structural stress. There is no skeleton with panels draped over it. The shape you see is the structure, and the structure is the shape. This is how aircraft fuselages are engineered. It's how the bodies of the most sophisticated racing cars are constructed. On a road-registered motorcycle sold to private buyers at $130,000, it is exceptionally rare and exceptionally demanding to execute correctly. Each monocell starts as pre-impregnated carbon fiber cloth, pre-preg in the industry, where the woven carbon fibers are already saturated with uncured resin before the layup begins. These sheets are cut to precise templates and placed into machined aluminium molds by hand, layer by layer. Each layer is orientated at a specific angle relative to the previous one, and that angle isn't arbitrary or aesthetic. Fibre orientation determines where the finished structure is stiff in bending, where it resists torsional twist, and where it's permitted to flex. Get the orientation wrong, and you have carbon that fails in tension at exactly the moment it needed to be strongest in compression. The Arch workshop doesn't get this wrong, but getting it right requires experienced hands, deliberate work, and a refusal to move faster than the quality demands. Once the layup is complete, the mold goes into an autoclave, a heated pressure vessel, where the resin cures under both heat and pressure simultaneously. The pressure drives out air pockets trapped within the laminate. The heat initiates and completes the chemical cure. The resulting laminate has a higher fibre-to-resin ratio than anything achievable through hand lamination at room temperature, lighter and stronger, without compromise between those two properties. The autoclave process is also slower and considerably more expensive than alternatives. There is no shortcut that produces the same material result. After curing, every panel undergoes ultraviolet light inspection for internal voids, delaminations, or any deviation from the approved specification. Any panel that doesn't pass is scrapped, not repaired, rebuilt from zero. At this stage in the process, some panels represent multiple days of skilled hand labor. Arch scraps them anyway. That single operational decision tells you more about this company's standards than any marketing material ever could. Now, the fitting. This is what the entire enterprise is built around. When your order is confirmed, you travel to the Arch workshop in Los Angeles, not to choose a color from a catalog, to be measured. Gard Hollinger's team places you on an adjustable mock-up rig, a purpose-built steel framework that can be configured to any combination of seat height, handlebar position, handlebar height, and foot peg location. They observe how you naturally position yourself when you stop thinking about it, where your arms settle when your shoulders genuinely relax, what angle your elbows find at a given handlebar height, how your knees track at various saddle positions, whether you carry tension differently on your left side versus your right after 30 seconds of sitting still. All of it goes into a detailed document. That document becomes the engineering specification for your motorcycle. Your handlebar height will match your natural resting arm position, not an industry average built around the statistical center of human body dimensions, not a compromise the manufacturer made when they imagined the range of buyers who might purchase the bike. Your position. Your foot pegs will be positioned so your knee angle when seated is correct for sustained distance, not bent sharply enough to cause cramping after 90 minutes, not extended to where your legs are working to maintain contact with the pegs rather than simply resting there. The whole cockpit geometry gets built around the dimensions of one specific human body. Yours. Keanu Reeves has spoken in interviews about why this matters in practice. The core idea is that a motorcycle built to fit its rider removes all compensation work. You're not shifting in the seat, searching for a comfortable position. You're not carrying tension in your shoulders because the bars are fractionally too close or too far. You're not using leg muscle to stabilize yourself against foot pegs that aren't quite placed correctly. Every bit of energy that would otherwise go into managing an imperfect fit stays available for the actual business of riding the motorcycle. The fatigue profile across a long day changes in ways that are real and measurable. Your responses when the road demands something sudden are cleaner. This isn't ergonomic luxury, it's chassis tuning by a different means, and its effects are genuine. Then the bike is built. 12 to 18 months of fabrication, quality checks, and hand finishing. When it's ready, Keanu rides it. He notes anything that needs addressing. It gets addressed. The bike ships when that step is complete. Every time. No exceptions have ever been made. If you're finding this level of detail useful, subscribing now means you won't miss the rest of this series. There are 9 more episodes coming, and they only get more extreme from here. The engine is an S&S Cycle 143 cubic inch V-twin. S&S Cycle is a Wisconsin company that has been building high-displacement American V-twins since 1958. Not a Harley-Davidson subsidiary, not a catalog supplier, an independent engineering company that builds complete performance engines, the ones serious custom builders reach for when the Harley-Davidson range isn't sufficient. Their 143 cubic inch unit produces around 121 horsepower and 130 pound-feet of torque, 90 kilowatts and 176 newton meters. A Harley-Davidson Fat Boy, one of the most famous cruisers in the world, produces around 86 pound-feet of torque from its 114 cubic inch engine. The S&S in the Method 143 produces 50% more torque from 25% more displacement. It is a genuinely more powerful engine by any measure that matters in the real world. But the integration is where the engineering becomes genuinely interesting. On most motorcycles, the engine is a discrete unit bolted into a discrete frame. The frame carries structural load, the engine sits within it as a power source and nothing more. On the Method 143, the engine is a structural member of the chassis itself. The Monocell connects directly to the S&S engine cases, and the engine takes load as part of the complete assembly. Formula One cars have used this configuration for decades. It eliminates the redundancy of carrying both a structural frame and a structurally rigid engine in places where the engine can do the work. The result is a lighter, more compact, more torsionally rigid structure. But it demands that the engine be built to tolerances that support this role. Any deflection in the cases propagates directly into the chassis geometry. S&S builds the 143 to specifications that make this viable. That is a significant part of why Arch chose them over designing a proprietary engine. The torque character of the S&S 143 is also worth noting. Unlike a high-revving sport bike engine that delivers its power in a narrow band above 8,000 revolutions per minute, the S&S unit produces its torque low and sustains it across a wide rev range. You feel it from the moment you open the throttle in second gear. You don't need to chase the power band. The engine does the work at whatever speed you happen to be at, which suits the character of the motorcycle completely. Suspension is Öhlins throughout. Up front, NIX30 forks at 43 mm in diameter, with compression and rebound damping independently adjustable. At the rear, an Öhlins monoshock operating through a custom linkage Arch developed specifically for the Monocell geometry, also fully adjustable. Öhlins supplies MotoGP teams and most serious high-performance motorcycle manufacturers globally. Their presence here isn't branding, it's a functional requirement because the suspension configuration on your Method 143 needs to be dialed for your body weight and riding style specifically, and Öhlins units have the adjustment range and damping quality to make that meaningful. Brakes are Brembo, 4-piston radially mounted calipers at the front on 320 mm rotors. Single caliper at the rear. There's nothing better available in production motorcycle braking at any price. The cockpit is deliberately spare. A custom single-pod instrument cluster ahead of the handlebar riser. Speed, RPM, gear position, fuel level clock. Nothing else. No touchscreen, no Bluetooth, no riding mode selector. Arch chose not to include standard electronic rider aids as default specification. The argument is direct. If the fitting and the suspension setup have been done correctly, the electronics are compensating for problems that shouldn't exist in the first place. It's a philosophically consistent position. Whether it's the right position for every buyer is a separate question. The finish requires real attention, because it's one of the aspects that needs to be seen in person to be fully understood. Every painted surface is hand-finished, flatted between coats, color-sanded after the final coat, then hand-polished to a depth that standard automotive paint processes don't approach. Under direct light, the lacquer looks as if the color is sitting several millimeters below the surface rather than resting on top of it. That isn't a property of the material, it's the direct product of the hours a skilled person spent on that surface before the motorcycle was approved for delivery. Chrome components, where specified, are real electroplated chrome, applied by a California specialist who plates for the aerospace industry. Not decorative finish that chips at the edges after a couple of winters, the kind that's still there when the bike is 30 years old. So, is it worth $130,000? The Monocell chassis is one of the most considered structural solutions in contemporary motorcycle design. Efficient, elegant, and the result of applying aerospace engineering logic to a problem the broader industry hasn't recognized as a problem. The custom fitting process is genuinely unique at this price in the industry and produces an ownership experience that customers consistently describe in terms that simply don't apply to any other motorcycle they've owned. The S&S engine is powerful and proven. The Erlins and Brembo specification is the reference standard for their respective functions. And the build quality throughout, the carbon work, the paint depth, the chrome, every surface you touch, is at a level you won't find on any mass-produced motorcycle, regardless of what it costs. Honest reservations. The Method 143 isn't a track tool. At £490 with cruiser geometry, it's not trying to be. If maximum cornering speed at the limit is your priority, this is the wrong workshop. The 121 horsepower figure is genuinely strong, but is no longer exceptional at this price in the current market. The 12 to 18-month lead time is a real commitment from a small operation. However impressive the output, small operations carry inherent vulnerabilities. The absence of electronic rider aids will frustrate some buyers, regardless of the philosophical argument behind it. That's a legitimate objection, and not one Arch fully resolves. $130,000 is a significant commitment to a motorcycle that won't catch a slide for you. Buyers who ride in varied conditions and weather will feel that absence. It's worth being clear-eyed about before you put down a deposit. But here's what this company has actually proven over 15 years. A small Los Angeles workshop can produce motorcycles that compete on build quality with manufacturers who've been doing this for generations. The custom fitting process isn't a marketing concept. It has measurable consequences for how a motorcycle rides and how long a rider can sustain their best performance. And a celebrity co-founder can be genuinely involved rather than decoratively attached. Keanu Reeves rides his own product for pleasure. He has personally ridden and approved every motorcycle Arch has ever shipped. That isn't a brand story, that's a production standard. In the last episode, we looked at a small workshop in Bologna applying a similar commitment from a completely different engineering direction. 5 motorcycles built by pulling apart a $72,500 Ducati and rebuilding it from nothing until it weighed less than the manufacturer's own MotoGP machine. If you haven't seen that episode yet, it's worth going back. Next time, we're inside a motorcycle from a manufacturer that set a production limit of 500 units. Not because they lacked buyers, but because the engineering they'd committed to couldn't be scaled further without compromising it. Carbon fiber bodywork that simultaneously functions as the structural airbox. A 4-cylinder engine sharing its fundamental architecture with the machine currently competing in the most contested championship in motorcycle racing. Road registered. We'll find out exactly how close they came to building something that wasn't legally rideable on a public road and why they decided the risk was worth taking anyway. This took considerable time to put together accurately. If you spot any errors in the technical detail, please let us know in the comments. We read everyone.